Learn SQL interview questions and answers, Part 1. If you're preparing for SQL interviews, this series is designed to help you build strong fundamentals and confidently answer common interview questions. In Part 1, we'll cover essential SQL concepts that every beginner and aspiring data professional should know. Here are two of the top SQL interview questions every data professional should know. Question 1. How do you find duplicate records in a table? To identify duplicates, use the Group By clause along with Count Star. Select Column 1, Column 2, Count Star from your table, Group By Column 1, Column 2, having Count Star greater than 1. This query groups records based on Column 1 and Column 2, then filters only those groups where the count is greater than 1, revealing duplicate records instantly. Question 2. How do you retrieve the second highest salary from an employee table? A common interview favorite. Select Max Salary as second highest salary from Employee. Where salary is less than, select Max Salary from Employee. Here's how it works. First, the subquery finds the highest salary. Then, the outer query selects the maximum salary below that value, giving you the second highest salary. These SQL patterns are essential for interviews and real-world database problem solving. Let's continue with two more essential SQL interview questions that every aspiring data professional should master. Question 3. How do you find employees without a department using left join? This is a practical example of using left join to identify unmatched records. SQL. Select E.** from employee E, left join department D on E.department ID equals D.department ID, where D.department ID is null. Here's how it works. The left join returns all employees, even if they don't have a matching department. By filtering where department ID from the department table is null, you can quickly find employees who are not assigned to any department. This technique is extremely useful for data validation and identifying orphan records. Question 4. How do you calculate total revenue per product? A classic aggregation question. SQL. Select product ID, sum of quantity times price as total revenue, from sales. Group by product ID. This query multiplies quantity by price for each sale, then sums the results for each product ID. The outcome? You get the total revenue generated by every product. This pattern is widely used in sales analysis, business intelligence, and reporting dashboards. Let's explore two powerful real-world SQL interview questions focused on customer analytics and business intelligence. Question 5. How do you find customers who made purchases but never returned products? This is a great example of combining join, distinct, and not in. SQL. Select distinct C.customer ID from customers C. Join orders O on C.customer ID equals O.customer ID, where C.customer ID not in select customer ID from returns. Here's how this query works. First, it identifies customers who have placed at least one order. Then, it excludes any customer IDs found in the returns table. The result? You get a clean list of customers who purchased products but never returned them. This type of query is valuable for customer loyalty analysis and retention strategies. Question 6. How do you find churned customers with no orders in the last 6 months? A crucial business metric for understanding customer disengagement. SQL. Select customer ID from orders. Group by customer ID. Having max of order date less than date add month -6 get date. Here's the logic. For each customer, the query checks their most recent order date using max of order date. If that latest purchase was more than 6 months ago, the customer is considered churned. This query is widely used in customer retention, marketing campaigns, and predictive analytics.
Question 7. How do you calculate the average order value per customer? This query helps businesses understand customer spending patterns. SQL. Select Customer ID, AVG, Total Amount as Average Order Value from Orders, Group by Customer ID. Here's how it works. The average function calculates the average total amount spent by each customer, while group by customer ID ensures the calculation is done individually for every customer. The result? You get each customer's average order value, which is useful for segmentation, loyalty analysis, and revenue forecasting. Question 8. How do you get the latest order placed by each customer? This is a common question for tracking customer activity. SQL. Select Customer ID, Max, Order Date as Latest Order Date. From Orders, group by Customer ID. Here's the logic. For each customer, the Max Order Date function identifies the most recent purchase date. The outcome? You instantly know when each customer last placed an order. This type of query is widely used in customer engagement analysis, remarketing campaigns, and sales monitoring. Question 9. How do you show product sales distribution as a % of total revenue? This query calculates how much each product contributes to overall sales. SQL. With total revenue as select sum quantity times price as total from sales, select s.product_id, sum of s.quantity times s.price as revenue, sum of s.quantity times s.price times 100 divided by t.total as revenue PCT, from sales S, cross-join total revenue T, group by s.product_id t.total. Here's how it works. First, the common table expression, or CTE, calculates the total revenue across all sales. Then, each product's revenue is calculated individually. Finally, each product's revenue is divided by the total revenue and multiplied by 100 to determine its percentage contribution. The result? You get revenue plus each product's share of total business revenue. This is essential for product performance analysis, Pareto analysis, and strategic decision-making. Question 10. How do you retrieve customers who made consecutive purchases within 2 days? This question highlights the power of window functions like lag. SQL. With CTE as select ID, order date, lag of order date over partition by ID, order by order date as prev_order date from orders, select ID, order date, prev_order date from CTE, where date diff of day, prev_order date equals 1. Here's the breakdown. The lag function retrieves the previous order date for each customer. By partitioning by customer ID and ordering by order date, you compare each order to the prior purchase. Then, date diff identifies customers whose purchases occurred on consecutive days. The outcome? You can detect highly engaged customers, repeat buying behavior, and purchasing trends. Mastering CTEs, revenue analysis, and window functions like lag can significantly elevate your SQL expertise and prepare you for advanced data engineering or analytics interviews.
Let's explore 2 advanced SQL scenarios that are highly valuable for business intelligence, analytics, and technical interviews. SQL sales query. How do you get the product with the highest sales for each category? This problem uses ranking functions to identify top-performing products across categories. SQL. With category sales as, select category ID, product ID, rank over partition by category ID, order by sum amount descent as sales rank. From sales, group by category ID, product ID. Select category ID, product ID, total sales. From category sales, where sales rank equals 1. Here's how it works. First, the common table expression calculates product rankings within each category. Rank assigns a rank based on descending sales amounts, partitioned by category. Then, the final query filters only rank 1 products, which represent the highest selling product in each category. This query is essential for category performance analysis, top product identification, and sales strategy optimization. Customer churn check. How do you find customers who haven't ordered in the last 6 months? This is a crucial customer retention and churn analysis problem. SQL. Select customer ID from customers C. Left join orders O on customer ID equals order ID. Group by customer ID. Having max of order date is less than current date minus interval 6 months, or max of order date is null. Here's the logic. The left join ensures all customers are included, even those with no orders. Max of order date identifies the most recent order for each customer. If the latest order is older than 6 months, or if the customer